This week on The Agent Factory.
So today we're going to pull back the curtain on a complete agent that we built from scratch.
We're kind of seeing a new wave of open source models optimized specifically for some of these agentic tasks.
This is a whole different level of complexity. Welcome back to the Agent Factory.
Today, we're diving into a crucial aspect of agent development, building custom tools.
So not just using existing APIs, but creating the specific tools your agent needs to interact with your own unique data and systems.
My name is Amit Maraj.
And I'm Smitha. Amit, it feels like the whole AI paradigm is shifting. It's less about just asking a model a question and more about giving it a job to do in the real world. A crucial aspect of agent development is building custom tools. This is more than just about plugging into existing APIs. It's like teaching your agent a new skill that only your team needs, giving it the exact abilities to do its job perfectly.
Yeah, that's right. But for an agent to do a real world job, it can't just rely on static, outdated knowledge, right? It's like using a GPS from 2023 to navigate today's traffic. You're going to miss things. And that's kind of the fundamental problem that developers are trying to solve right now, it seems.
So how are they solving it? How do you give an agent that live connection to the world without making things overly complex?
Yeah, I think that's the golden question, right? So the solution, from what it seems, is to equip the agent with what seems to be a toolkit. And the most critical tool for accessing live data, it seems, is Retrieval Augmented Generation. We've seen this over the past few years become super popular. Actually, a recent research paper that came out from the University of Liverpool actually showcases how their deep research agent works. And it's giving a great example of agentic RAG, giving their agent RAG functionality is almost like a custom tool, if you will.
For those of you who are listening, we are showing a diagram on screen.
The agent is designed to be smart. It reasons about a task and recognizes when its internal knowledge just isn't enough. So it makes a choice to use its RAG tool. And it's not just automatic. It's a deliberate action to go and finally look something up. The tool kind of connects to databases or the web. It fetches current relevant information and brings it back to the agent. The agent has to kind of think about what to do next. And this helps overcome major issues like hallucinations and stale data by almost grounding the agent in verifiable facts.
So that actually makes complete sense. It's a deliberate, intelligent action rather than a passive, automatic one. So the agent seems to be truly in the driver's seat. This agent-first approach must be influencing how new models are being developed.
Absolutely. We're kind of seeing a new wave of open source models optimized specifically for some of these agentic tasks. Two that are getting a lot of attention right now are Kimi K2 from Moonshot AI and Qwen 3 from Alibaba. But for our developers listening right now who want to build these kinds of agents, what are the key differences? When might they want to choose one over the other?
Oh, Amit, I've been doing so much research on both of these models. I want to boil down the key differences for us between Kimi K2 and Qwen 3. So Kimi K2 excels at complex autonomous tool use. It's described as reflex grade, and it can execute multiple step jobs.
For those of you who are listening, we're showing a diagram on screen.
Without intervention. It's like a demo where it ran 16 consecutive Python commands to analyze data. So it was able to run that successfully. It's also the top choice for building highly independent agents that handle sophisticated workflows. Meanwhile, Qwen's 3 key feature is direct control over the reasoning process. Its hybrid thinking modes let you command the model with a command called think for detailed step-by-step logic on really hard problems. Or also you can use a command called nothink for instant answers on simple queries, giving you explicit control over the speed versus accuracy trade-off. So Qwen 3 has a massive advantage in that it has multilingual support. It covers over 100 languages. So if you're building an agent for an international audience, this native capability makes it the ideal choice for global reach.
Well, it's really cool to have all of these powerful options now, but As every developer knows, having a great model is really only half the battle, right?
And then wiring everything together, the agent logic, the model calls, the tools, it can lead to really brittle and complex code.
Precisely. And that's kind of the problem that Google DeepMind is targeting with their new open source library called GenAI processors. For those of you who are listening, we're showing a diagram on screen.
Wow. So high level, how does that make a developer's life easier?
Yeah, so really it's just a Python library that's designed to simplify building complex, real-time, and multimodal AI apps. The core concept is the processor. It's like a modular building block for a specific task, like capturing audio or calling a model, for example. The magic is actually how you combine them, though. You can build a sophisticated pipeline just by chaining these blocks together with a simple operator. For example, input processor plus model processor plus output processor. You can see how it's able to do this in parallel. The library automatically handles all of the difficult asynchronous logic in the background. It basically removes the headache of managing concurrency and allows developers to focus on the application logic instead of the plumbing.
That sounds actually incredibly powerful, but a powerful engine without great wiring is also really hard to work with. Connecting the model to your tools is where the real complexity begins. So how do you do that?
Yeah, it's a really good point, actually. So it seems that Google is trying to tackle this from a completely new angle, actually. Just last week, they announced an experimental tool from Google Labs called Opal.
Opal, okay, so what's the big idea here? Is this another developer library for really hardcore coders?
Yeah, actually, it's the opposite. Opal is a no-code tool designed to let anyone build and share AI mini apps. Now that everyone's building apps with AI, it seems like there's a lot of them floating around. So the goal is to dramatically lower the barrier to entry for sharing them.
For those of you who are listening, we are showing a diagram on screen.
The core concept is the workflow. You use simple, natural language to describe the series of steps you want the AI to take. For example, take a meeting transcript, find the action items, and then create a follow-up email. So Opal can actually do this by automatically translating your description into a visual workflow, like a flowchart with blocks for prompts, model calls, and other tools. The magic is that you can kind of take this, edit it, and then, drag your visual blocks around, or just tell Opal in plain English, add a step to translate the email into Japanese. So for developers, it's an incredible tool that allows for rapid prototyping and building proofs of concept. And for non-developers, it's a way to create powerful custom AI tools for their own productivity without writing a single line of code.
Amazing. That sounds like a huge step for simplifying the engineering. And it opens up AI creation to a lot more people.
Exactly. I can't really wait to see what people build.
This is the part of the show where we deep dive and actually build something. Today, we're tackling something which I think is at the heart of making really great agents, and that is building custom tools.
Yeah, this is a topic I really love. An agent's brain is powerful, but it's kind of stuck in a box until we give it arms and legs to interact with the world around it. The tools are what lets it do things.
Exactly. So today we're going to pull back the curtain on a complete agent that we built from scratch called FinWise. Think of it as your own personal finance and investment analyst. It's built entirely with Google's new Agent Development Kit, or ADK. The whole idea was to see if we could build an agent that could handle a really complex, multi-step request from a user in just one go.
And that's why we came up with the perfect prompt to really push the agent to its limits. Let's show you what it looks like when a user types this prompt into the FinWise app UI. Analyze my portfolio's performance over the last year and plot its growth against the S&P 500. Then, using my aggressive risk profile, recommend an optimized allocation. Once you have a recommendation, what's the current price of the top new stock in that list? If I approve, buy 10 shares of it.
Okay, so no pressure, right? That one request can be broken down into 4 different tasks that involve data analysis, heavy computation, data fetching, and secure authenticated actions. A simple agent would just give up.
But an agent with a well-designed toolkit can actually break that down and tackle each piece. We ended up with a really cool architecture where a main agent actually uses a suite of different tools to get this job done.
And what's wild is that one of those tools is actually another agent in disguise. But we'll get to that in a little bit. So let's tackle that prompt piece by piece that Amit introduced, right? So the first thing the user asks is to analyze and plot its growth. Now, that's a totally unpredictable request because of how open-ended it is. Analyze what? And so I'll kick things off on how we handle that.
Yeah, you can't write a function for every possible analysis a user could dream up, right? How did you tackle that, Smitha?
So for that, you need to use ADK's built-in code execution tool. It basically gives the agent its own Python environment to write and run code on the fly. But there's a catch, a really important design rule in the ADK. An agent that uses a built-in tool like this can't have any other tools.
Oh, wow. Okay, so you couldn't just add it to our main agent's toolbox, it seems? Like, what's the workaround here?
The workaround is a really elegant architecture called agent as a tool. You create a specialist agent whose only job is to execute code. So you can see we're creating the LLM agent and giving it the built-in code executor.
For those of you who are listening, we're showing a code snippet on screen.
But that instruction string is really key. It's essentially the prompt for our specialist agent. We're telling it, you are a Python financial data analyst, and here's what you need to return. This guides the agent on how to behave and what code to generate for our financial analyst tasks. And also, it makes use of Gemini 2.5 Pro to do the rest.
That's really clever. So it's like a little worker agent with its own set of instructions, it seems. Like, how does our main agent talk to it then?
So you just have to wrap it. There's a class in ADK called Agent Tool, and that's perfect for this. We actually then pass our entire FinWise analyst agent object into that. And then we can add this new agent tool to our main agents list of tools. It's actually a really smart way to build a modular system that respects the framework's rules. Okay, so our agent can now analyze and plot historical data. The next part of the user's prompt was to recommend an optimized allocation. This is a whole different level of complexity.
Right. A real Monte Carlo simulation is a beast. It's incredibly computationally heavy. I mean, I definitely wouldn't want something like that running inside of my main agent's process, right?
Exactly. That's a perfect use case for our next pattern of tool. For something that heavy and specialized, we built it as a proper standalone service using the Model Context Protocol, or MCP. Think of MCP as creating a universal plug for AI tools. We build our optimizer as a separate server, and now any agent that understands MCP can connect to it.
Okay, so if I'm understanding this correctly, you're basically publishing it as a reusable piece of capability?
Precisely. So to make that happen, the server needs a way to advertise its capabilities. It does that with a really special function that acts as a MCP handler.
For those of you who are listening, we're showing a code snippet on screen.
It's a Python function called list_tools, and it has a decorator, app.listtools. When an agent connects, it calls this function to ask, what tools do you have? Inside, we have a handy utility from the ADK to convert our internal optimizer tool into the standard MCP format. We then just return a list containing that tool's definition. It's like the server handing the agent its business card.
Okay, so that makes a lot of sense. But, that's kind of how the agent just discovers the tool. How does it actually connect and use it then?
So on the agent side, it's surprisingly simple. We use a class called MCP toolset. This MCP toolset object is like a smart connector. Its whole job is to manage the connection to our server and make its tools available to our agent. We tell it how to connect using a parameter called connection params. In the code, we set this to server parameters, and we pass it two things: the command, which is Python 3, and the arguments, which is just the path to our server script.
Okay, so it's not connecting to a URL, it seems. It's actually just running the script itself?
Exactly. The MCP toolset literally launches our server as a background process and talks to it directly over standard I/O. It handles everything. So from our agent's perspective, the powerful portfolio optimizer just feels like another built-in tool. So Amit, once my MCP tool comes up with this great new portfolio, the user wants to know what's the current price of the top new stock. This feels like it's in your wheelhouse.
How did you know? It absolutely is. So this is the most straightforward task in the whole prompt. Probably it's why it's in my wheelhouse. It's a classic, I need one piece of data from an API type problem. But for that, we have a standard function tool, which is the perfect choice for this. It's simple, it's stateless, and it's the most direct way to give your agent a new capability.
So, for people listening, how easy is it to turn a regular Python function into something an agent can actually use based on what you're saying?
Yeah, surprisingly, it's almost deceptively simple. The magic is this one little decorator. You just add adk.tools.function_tool on top of your function, and that's it. You've registered it as a tool that the agent can see and use.
Okay, but how does the agent know what the function get stock price does or how to even use it?
Yeah, good question. I mean, this is the next critical piece, which is the doc string. And it's not just useful for us developers, it's actually useful for agents as well. The LLM literally reads this to understand what the tool does. It's like prompt engineering, but for your tool. You have to be clear about what it does and what arguments it needs, as you can see here. Once the agent decides to use it, the code inside is just a standard API call that you can modify to call any financial API, really. Okay, so checking the price is easy, but the final and most critical step in the prompt is when a user says, if I approve, buy 10 shares of it. This is where we have to be incredibly careful with security.
Absolutely. So, this is actually the most critical part. So, how did you approach the authentication piece?
Yeah, good question. So for this, we have to build an authenticated function tool. The ADK pattern for custom tools like this put the auth logic right inside of the function itself. And it all revolves around a special object called the tool context. We define our function as execute trade, and along with the expected parameters like stock we are buying, we add a special final parameter, tool context. And we make sure that it has a type hint, tool context. This is the key. You don't pass this in yourself. The ADK framework automatically injects this tool context object every time the tool is called. It's our secure bridge to the agent's session state.
Wow, that's awesome. So, the tool context is how the tool gets its special powers, basically.
Yeah, that's exactly correct. And the very first thing that the function does is actually it uses that context to check the session state to see if we already have a token for the user.
So, you're actually avoiding making the user log in over and over again. It seems that's actually huge for user experience.
Yeah, that's right. And, if we don't find a valid token, the tool itself has to ask for one. And once that is taken care of, it can then proceed to the final step, which is making the actual API call to finally buy the stock. This pattern kind of ensures that our most sensitive action is protected every step of the way.
Wow, it's really incredible when you see it all come together. We started with just this one massive complex prompt, and by choosing the right tool for each part of the job, we've architected an agent that can actually handle it, from a simple API call all the way to a secure authenticated action.
It really shows that building a great agent isn't just about the LLM. It's about the quality and architecture of the tools that you choose to give it. And with that foundation laid, we've got a great question from a listener who's working with a large REST API and it has dozens of endpoints. They ask, is there a more efficient way to integrate my API than by writing a separate tool call for every single API endpoint? The answer is yes, and it's a huge time saver. Manually creating a tool for every endpoint would be a nightmare to build and maintain. This is the exact problem that the OpenAPI toolset is designed to solve. It's a powerful feature that makes your AI agent API aware without all that tedious manual coding.
For those of you who are listening, we are showing a code snippet on screen.
So you can think of your OpenAPI specification as an employee handbook, but for your API. You provide this blueprint to the toolset, and it automatically discovers every valid operation and generates a ready-to-use tool for each one of those endpoints. It pulls names and descriptions directly from your documentation, and this creates a powerful bridge to your existing architecture. This transforms a massive coding effort into a simple configuration step, essentially. This gives your agent the ability to act as a smart client, which can intelligently interact with your pre-existing business logic right out of the box.
That's honestly amazing. Next, we also have another question from a developer who asks, many of us already use frameworks like LangChain. Can I reuse my existing LangChain tools with the new ADK? And the answer is a big yes. The framework is designed to be open and work with tools you've already built.
For those of you who are listening, we're showing a code snippet on screen.
It provides a dedicated LangChain tool wrapper to make this easy. Think of the wrapper like a simple travel adapter. You just plug your existing LangChain tool into it, and it works instantly inside your new ADK agent. The goal is simple. You should be able to use the best tool for the job without having to throw away good work or rewrite your old code.
Well, that's really cool. It makes it very approachable to mix and match code, I guess. So, okay, this next question gets into some really powerful advanced use cases. One of our listeners asks, what if my tool needs to perform a long-running task, like rendering a video or running a complex analysis? How do I prevent this task from blocking the entire agent? This is actually a critical problem because obviously these asynchronous tasks show up in agentic systems all the time.
For those of you who are listening, we are showing a code snippet on screen.
And a blocked agent is an unresponsive agent. The solution for this is a specialized tool called the long-running function tool, which is designed specifically for these asynchronous jobs that might take seconds, minutes, or sometimes in video processing, even hours. But here's the clever part. When the agent calls the tool, it goes ahead and kicks off the long asynchronous process, which returns essentially a tracking ID. It's like an identifier. The agent can then pause the specific task without blocking the entire system. So when the job is finally done, an external system like a webhook processes the final result and the agent resumes its work. This ability to handle asynchronous operations elevates an agent from a simple conversational partner into a true autonomous assistant or process orchestrator, if you will, which can manage complex, multi-step business processes over time. And that's all the time we have for questions today. It's incredible to hear about all of the complex challenges our listeners are tackling.
It really is. From our discussion on the latest industry trends to our deep dive building the FinWise agent, one theme is crystal clear. A great agent is defined by the quality and architecture of its tools. We really hope today gave you a practical roadmap for building your own.
Yeah, and we've covered so much ground today, from using an agent as a tool for dynamic code execution to wrapping services with MCP and creating simple and secure function tools for every use case in between. It all comes back to choosing the right tool for the job.
A huge thank you to all of you for tuning into the Agent Factory. You can find links to all the research papers, code snippets, and tools we discussed today in the description below.
Until then,
shutting down.